Hello everyone, welcome to my YouTube channel Self Study. Today we will continue the chapter number 8, electricity, and this is the last chapter of physics class 8. So in this chapter you will learn about describe household consumptions of electricity, identify live wire, neutral wire and earth wire in terms of their energy and path they travel. Describe safety components like fuse, circuit break, etc. Describe phenomena of static electricity, explain conservations of a charge, describe conductions and working of a electroscope, describe a lightning conductor, identify charge, identify dangers of electricity, and so on. So continue the chapters. So electricity chapters is divided into two parts. Part A, that is household circuits, and part B is a static electricity. Part A is a household electricity and part B is a static electricity. So in this video we will cover the part A, that is household electricity. So continue introductions. In our daily life we all use electricity in different ways, such as to light our home, school, office, etc., to run fan, television, heater, radio and all other electrical appliances. The different sources of electricity are cell, mains, electric generator or dynamo, and solar cell. In earlier classes you have read the use of cell in torch, watches, calculator, remote control, etc. Means you have already read how to use the cell or battery in torches, watches, calculator, remote control, etc. And in this chapter we shall study the use of mains as a source of electricity for household purpose. The cells or battery provide us current. The cells and battery provide us current which remain constant with time. This current is called direct current, means the current which is provided through cells or battery is called direct current or DC. The mains and electric generator provided us the alternating currents, but the mains and electric generator provide us a alternating current which change its magnitude and polarity with time. Generally we use AC current. Generally we use at home AC current of frequency 50 Hz, in which the polarity is 50 times positive and 50 times negative in each 1 second. Now electrical energy and power consumptions in a circuit. In class 7 you have read that current from a cell flow in a circuit due to the motions of electrons in the metallic wire used in that circuit. Means you have already read that current from a cell flow in a circuit due to the motions of electrons. How current is generated? Due to the motions of electrons in a metallic wire used in that circuit. A cell has a potential difference between its electrode, namely the anode and cathode. Means cells has potential difference between its electrode, namely cathode, anode and cathode. Anode is positive charge and cathode is negative. Potential difference is defined as the work done in moving a unit charge from one electrode to another electrode. So underline this. What is potential difference? Potential difference is defines as work done, means how much work is done in moving a unit charge from one electrode to another electrode. It is expressed in a unit volt, symbol V. Means potential difference is expressed in a unit that is called volt or symbol V, capital V, after the name of the scientist Alessandro Volta. We have defined current as a rate of flow of charge in a unit time. So definitions of current is a rate of flow of charge in a unit times. It is measured in ampere. Current is measured in ampere after the name of the scientist Andre Marin Ampere. In figure 8.1, that is figure 8.1, suppose a current I flow through a conductor of resistance R. Current I flow through a flow through conductors have resistance R for time t. When a source of potential difference V is connected across its ends, that is called potential difference is connected end, we are to find the amount of electrical energy supplied by the source. By definitions, potential difference is the work done in moving a unit charge. So work need to move a charge Q through the potential difference V. So work done is equal to Q into V, charge into potential difference, but current I is equal to charge by time, Q is equal to I into T. Hence W is equal to work is equal to V into I into T. This gives the electrical energy W supplied by the source, that is battery or mains, in providing the current I for time t in the conductor under a potential difference V. Now power is a rate of doing work. Definitions of powers is a rate of doing work. So power supplied by the source P is equal to W by T. So W we have already find, W is equal to V into IT. IT is equal to Q is equal to IT, charge, by T. So power is equal to V into I. T will T cut. Thus power in watt, potential difference in volt into current in ampere. Thus 1 watt in is equal to 1 volt into 1 ampere. So 1 watt is equal to 1 volt into 1 ampere. Transmissions of power from the power generating stations to the consumer. Electric power is generated at the power generating stations, which are usually located very far from the areas where it is consumed. At the generating stations, the electric power is generated at 11 kilovolt, means kilovolt. At generating stations, means main stations, the electric power is generated at 11 kilovolt. The voltage generated has alternating frequency of 15 Hz. 15 Hz. Its polarity of at the terminal change 100 times a second, 50 time plus and 50 time minus. The voltage of the power generating at the generating stations is first raised from 11 kilovolt, means 11,000 volt, to 132 kilovolt to reduce loss of energy in transmissions due to heating of line wires, and then is transmitted to the grid substations. After it transmitted to the after it reduce the loss of energy in the transmissions, then it transmit to the grid substations. At the grid substations, its voltage is reduced from 130 kilovolt to 33 kilovolt. Again, from substations, its voltage is reduced from 130 kilovolt to 33 kilovolt before it is sent to the main substations, and then it's sent to the main substations where its voltage is further reduced, and again its voltage is reduced to 11 kilovolt. Once reduced, the power is supplied to the city substations where its voltage is further reduced, and when power is supplied to the city substations, their voltage is further reduced to 220 volt before it is supplied to the consumer. Means we consumes only 220 volt of power. Supply of power to a house. To supply electric power to a house from the city substations, either the overheated wire or cable on pole or an underground cable is used. The cable has 3 wires. Underline this, the cable has 3 wires: live wire or phase wire, that is denoted at L, neutral wire or N, earth wire denoted at E. The neutral wire and the earth wire are connected together. Note that a neutral and earth wire are connected together at the local substation so that the neutral and earth wire are at the same potentials. Example, at 0 volt, The live wire also called phase wire. The live wire is also called phase wire. It is at 220 volt and it carry current from the source to the distribution board, and live wire carry current from source to the distribution board, while the neutral wire is for the return path of current. For the return path of current, the earth wire feeds the current to the earth and earth wire passes the current to the earth. Now color coding of live, neutral and earth wire. In the cable, the live, neutral and earth wire have insulations of different color, so they can be easily distinguished. Live wire is a red or brown. Remember this, live wire is always red or brown. Neutral wire is always black or light blue. Earth wire is always green or yellow. To summarize, the voltage, color and the purpose of the three wire are given below. Live wire, color red or brown, voltage 220 volt. What is the purpose? To carry current from source to the appliance. Neutral wire, black or light blue, 0 volt. Purpose to provide the return path from appliance to the source. Earth wire, green or yellow, voltage 0 volt to provide connections to the earth. Now connections from pole to the distribution board. To connect the cable from pole to the meter in a house, first a fuse of high rating 50 ampere is connected in a live wire at the pole or just before the meter. Means a fuse of high rating 50 amperes is connected in a live wire at the pole before the meter. This fuse is called company fuse or pole fuse, and this fuse is known as company fuse or pole fuse. Only electric supply company staff are authorized to handle it, and this fuse are only electric supply company staffs are authorized to handle it. The rating of the fuse depends on the load for which connections is taken from the company. After the company fuse, the cable is connected to an electric meter. The electric meter is usually mounted on the front or outside wall of the house. From the meter, connections are made to the distribution board through a main fuse and a main switch. The main fuse is connected to the live wire. The main fuse is always connected to the live wire, while the main switch is connected to the live and neutral wire. While the main switch is always connected to the live and neutral wire. Now, commercial unit of electrical energy. Electrical energy is generally measured in a unit called BOT, that is Board of Trade Unit, or kWh, kilowatt hour. Electric appliance of power 1 kilowatt is used for 1 hour. The energy consumed in our house, shop, factory, etc. is measured in kilowatt hour. Power is equal to energy by time. So energy is equal to power into time. Energy in kilowatt hour is equal to power in kilowatt into time. Hence 1 kilowatt is equal to 1 kilowatt. 1 kilowatt hour is equal to 1 kilowatt into 1 hour. So 1 kilowatt is equal to 1000 watt into 1 hour is equal to 60 into 60 second. So total 3.6 into 10 to the power 6 joule. Electric meter. Electric meters is also called kilowatt hour meter because it measures the amount of electric energy consumed by the consumer in the unit kilowatt hour called kilowatt hour for which the electricity bill is paid. Means the meter we use is always measured in kilowatt hours by him to the electricity board. In figure 8.2, that is kilowatt hour meter. So a kWh meter, the main part of the meters is the armatures. That is a, the main part of the meters is armatures, which is connected to the main lines. When any electrical appliance is put on it, when any electrical appliance is put on the armatures, on the electrical current flow which rotate the armatures. The counter fixed on the armatures read the number of rotations, and by reading the number of rotations the bill amount is displayed on the board. The 5 dials on the counter reads electricity consumptions direct in kilowatt hour unit as shown in figure 8.3. As you see in figure 8.3, working of household electric meters. These 5 dials from right to left measure the energy in unit, tens, hundred, thousand and 10,000 respectively. The reading on the meter is 49180 kilowatt hour. Nowadays, the old meters are being replaced by electronic digital meters. And nowadays, old meters are being replaced by electronic digital meter, which are totally different from the meters shown above. And this is the old meters, and now we use the electronic digital meter. The following activity will make it clear how the electric energy. So activity number 1, that is about electric meter, I will discuss it later. Now electric fuse or a safety device. Electric fuse is a device which is used to limit the current in an electric circuit. Means electric fuse is a device which is used to limit current in an electric circuit. It safeguards the circuit and the appliance connected in the circuit from being damaged. If the current in a circuit exceeds or increase the specific value due to voltage fluctuations or short circuitings in figure 8.5, as you see in figure 8.5, that is electric fuse. Show an electric fuse arrangement commonly used in our household circuit. It consists of fuse wire. Electric fuse consists of fuse wire F, which is stretched between the two metal terminal 1 and terminal 2 in an porcelain holders. The holder fit into a porcelain socket. The fuse wires is a short or thin pieces of wire. Means fuse wire is so short and thin pieces of wire of a material of low melting point, and fuse wires have a low melting point. Generally, fuse wires is made up of alloy and lead and tin. Means fuse wires is made up of alloy, lead and tin, having 50% of each metal. Now what is the purpose of fuse wire? It is the insulations on the wire of cable using in wiring. Breaking the live wire comes in the contact with the neutral wire, which result in a short circuit. Maximum current then passes through the wire, which can cause burning of the wire due to the excessive heat. Similarly, due to voltage fluctuations, sometimes high current flow through the wire that can cause burning of wire. Means the purpose of fuse is to safety device. So to prevent this damage, a fuse is connected to the live wire of the current. When there is a short circuit, the fuse wire get heated up to the extent then that is melt. As a result, a gap is produced. Means when a short circuit, the fuse wires is heated, extend and it melt. As a result, a gap is produced in the live wire and the current circuit become incomplete or breaks. No current then flow and the appliance or the circuit is safe. After removing the fault in the circuit or appliance, a new fuse wire is fixed between the terminal 1 and terminal 2 in the holder to complete the circuit again. Note: nowadays the domestic gadgets such as oven, geyser, press, refrigerator, air conditioner, etc. are provided with a cartridge types of fuse in its line wire. Characteristics of a fuse. So point number 1, it is a short wire with a low melting point. So fuse wires is a short wire with low melting point. The fuse wire is made up of alloy of lead and tin, and fuse wires is made up of alloy of lead and tin. Its melting is about 200 degrees Celsius, and it melted about 200 degrees Celsius. Number 2, fuse wire is connected in series. Fuse wires is always connected in series with the live wire, and always with the live wire. Its temperature rises much faster than the connecting copper wire, and its temperature rises much faster than normal copper wire when an excessive current flow, because its resistance is high than that of the connecting copper wire. Now point number 3, the thickness of fuse wires is depend on the current rating of it. Higher the rating, thicker is the wire. It means that 50 ampere fuse is thicker than the 5 ampere fuse. The heating of fuse wire does not depend on its length. Means heating of fuse wire does not depend on its length. Note: an ordinary copper wire must not be used as a fuse wire. Means ordinary copper wire must not use as a copper wire because its melting point is much high. These days, miniature circuit breaker (MCB) are used. They switch off the circuit in a very short times, nearly 25 milliseconds in case of short circuit. Now, what is miniature circuit breaker (MCB)? A miniature circuit breaker in figure 8.6, this is called miniature circuit breaker, is an automatic switch that is nowadays used to protect the household wiring from the excessive flow of electric current in a circuit. Means it is also used as a fuse wire to protect the household circuit. When the current flow is in excess, the MCB automatically falls down. Means when current flow in excess, the MCB automatically falls down to break the electric circuit. It is reset after the fault is rectified. Household electrical circuit. In your house, you notice that each electrical appliance can be used separately. In your house, you have noticed that each electrical appliance can be used separately. Now now you can light a bulb without running the fan, or you can light a bulb in one room without lighting the bulb in the other rooms. Further, you can notice that if one bulb fuse or one appliance fails, it does not affect the working of the other appliance in the house. All the appliances work at the same voltage equal to the voltage of mains is equal to 220 volt. Now, the questions arise: how are the various appliances connected in circuit? To answer these questions, perform the following two experiments. Experiment number 1. Take two torch bulbs. Mark them as A and B. Take two torch bulbs. Mark them A and B. Two torch. Connected the two bulbs to a cell through a switch, and connect the two bulb A and bulb B, torch A and B, and switch them and connect it to the switch. As shown in figure 8.7, both the bulb glow when switch is closed. The bulb was said to be connected in series, and this bulb was connected in series. Close the switch. Now you close the switch, you will see that the both bulb glow. We will see that both bulb will glow when you close the switch. Now switch off and take out the connections of the bulb B. Now switch off and take out the connections of bulb B. Figure 8.8. In figure 8.8, again close the switch, and now again you close the switch. You will see that the bulb A does not glow because the circuit is incomplete. The reason is that the circuit is now incomplete. Now replace the bulb B by a fuse bulb as shown in figure 8.9. Now in figure 8.9, replace the bulb B with fuse bulb. Close the switch and then close the switch. You will again find that the bulb A does not glow since the circuit is incomplete. After connecting broken filament or fuse bulb A to bulb B, you will see that the bulb A will not glow because now still the circuit is incomplete. Experiment number 2. Connect the two bulbs, make A and B through the switch S1 and S2 to the cell as shown in figure 8.12. Now connect the bulb A with the switch 1 and bulb B with the switch 2. The bulbs are said to be connected in parallel, and this bulb are said to be connected in parallel. Close both the switch. Now you close both the switch. You will find that both the bulb will glow. So you will find that both the bulb will glow. Now close only the switch 1. Now you close the switch 1 only. So you and leave the switch 2 and open the switch 2. You will find that the bulb A glow, and you will find only bulb A is glow, but the bulb B does not glow, and bulb B does not glow because the switch is on, open. Then close only the switch 2. Then close only the switch 2 and leave the switch 1 open, and leave the switch 1 open. You will find that the bulb B glow, but the bulb A does not glow. Now replace the bulb B by a fuse bulb. Close both the switch 1 and 2. You will find that the bulb A will still glow, but the bulb B, being fused, does not glow. From the above experiment, you conclude that in series combinations, if one of the bulb is removed or it is fused, the other bulb does not glow on closing the switch. But in parallel connections, a bulb glow irrespective of whether the other bulb glow or not, or it is fused. Thus, it is clear that all the electrical appliances in our homes, office, school, factory, etc. are connected in parallels. So, in school, home, office, we have connected the electrical appliance in parallels. Each appliance has an independent path of current and work at the same voltage. Electric circuit in a room. Electricity is supplied to us at the voltage of 220 volt through a cable which has 3 wires, namely live wire, neutral wire and earth wire. From the distribution board, electricity is distributed to the various parts of the house such as room, kitchen, toilet, staircase, etc. All the electrical appliances are connected in parallel. Figure 8.14. Figure 8.1 for electrical circuit in a room. So, electrical circuit of a room having 2 bulbs and a fan, having 2 bulbs and a fan, and all have an individual switch. Each appliance has separated with switch connected with its live wire. In figure 1.84, electric earth wire has not been shown, and in this figure earth wire has not been shown. Earthing of the appliance. The metallic outer body case of each appliance such as refrigerator, oven, geyser, etc. is connected to the live earth wire. The reason is that sometime due to breaking of insulations of wire, live wire came in contact with the body of the appliance, and we get a fatal shock when the appliance is touched. If the appliance is earthed, the current will pass through the earth and we remain protected from the electric shock. Power rating of appliance. Generally, electric appliances such as electric bulb, geyser, heater, etc. is rated with power and voltage. For example, an electric bulb is rated as 100 watt to 200 volt. It means that if the bulb is lightened on a 220 volt supply, it consumes 100 watt electrical power. 100 joule of electrical energy is consumed by the bulb in 1 second, or in other words, 100 joule of electrical energy is converted in the filament of bulb into light and heat energy in 1 second. From the power rating of an appliance, we can find that safe limit of current which can flow through that appliance from relations P is equal to VI. Safe limit of current for an appliance, I is equal to power of appliance by voltage at which it works. For example, for a bulb rated 100 watt 200 volt. The safe limit of current when it is lighted at 220 volt, that is 220 volt, is I current is equal to power by volt 100 watt by 220 volt is equal to 0.45 ampere. The table given below the power rating of some common appliance. This is a table. Remember these tables. Important: car, electric bulb, fluorescent tube, electric fan, so television. Read this. Household consumptions of electrical energy. Every home using electricity has an electric meter which measures the amount of electrical energy consumed in that home over a given period of time. The electric meter is fixed at the main board or just outside our house. The electrical energy is sold in unit of kilowatt hour. It is a unit in which the consumer pays the cost of electricity. The electrical energy consumed by an appliance in a certain time can be calculated in kilowatt hour by the following relations. Energy in kilowatt hour is equal to power in kilowatt into time in hour is equal to power in watt into time in hour by 1000 is equal to volt into ampere into t an hour into 1000. Thus, total energy consumed by an electrical appliance in kilowatt hour can be calculated by multiplying its power rating in kilowatt with the time durations in hour for which it was in use. The cost of electricity will then be the product of energy consumed in kilowatt hour with the rate in rupees per kilowatt hour. Example: if an electric oven of power 3 kilowatt work for 2 hours per day, the electrical energy consumed by the oven per day will be 3 kilowatt into 2 hours equal to 6 kilowatt hour. While the total energy consumed in a month of 30 days will be 3 kilowatt hour into 2 into 30 hour is equal to 180 kilowatt hour. The cost of electricity at the rate of rupees 6.25 per kilowatt hour will then be 120 kilowatt hours is into 6.25 is equal to 1125 rupees. So now, hazards of electricity. Apart from the use of electricity, there are a number of its hazards too, which are given below. Number 1. When you use a number of electrical gadgets connected in a circuit at the same time, a heavy current flows through the connecting wire. In other words, the house circuit gets overloaded. There will be overheating of the electric wire, which may cause short circuiting and even electric fire. Number 2. Sometimes, due to poor insulations of wire, live wire touch the neutral wire, and when the live wire touch the neutral wire, this causes short circuiting and the flow of current become excess. This excess flow of current damages the electrical appliance such as TV, refrigerator, tube light, bulb, etc. Even the wire catch fire and there can be a mischief in form of electric fire. Number 3. If a person comes in contact with a live wire, he gets an electric shock. If it is a huge shock, it can cause death. Precautions to be taken while using electricity. Number 1. We should not touch switch with wet hand. It is a must. We should not touch the switch with wet hand. Number 2. The connecting wire to the plug, socket and switch should be tightly joined. Number 3. We should ensure that all the appliances are properly earthed. Number 4. We should not try to repair an appliance while it is in use. Number 5. We should ensure that the MCB or fuse and switch are connected to the live wire. Number 6. The wiring used must have proper insulations. Number 7. The ordinary copper wire should not be used as a fuse wire because the melting point of copper is 1080 degrees Celsius, so it will not melt even if the current exists exceed its safe limit. Number 8. To switch off the gadget like TV, geyser, press, air conditioner, etc., take out the plug from the socket instead of using the remote. And so this is a solve example. I will discuss it later. So thank you for today. Please subscribe to my channel for the second part, that is static electricity. So thank you.